Hello, in this video I will go over basic points about ICF and primarily will describe ICF Effect by reviewing a document published by Insulating Concrete Form Association a while ago. Just to save you time and going through links and looking for a document, I would like to read text that's inside the ICF Effect document and give you a chance to listen to some of the information that's there, which is crucial in understanding ICF and why it's so beneficial to those who decide to build with ICF when planning and constructing their new home or commercial property. So quickly, what is an ICF? IntegraSpec, or any other ICF technically, is insulating concrete form consisting of two panels of expanded polystyrene, which is EPS, married with high impact polystyrene inserts used to hold patented webs, spacers designed to secure rebar as needed in place. Once stacked together, these forms represent a mold ready for concrete placement, similar to a traditional poured concrete wall. However, ICF forms never leave the concrete, providing a multitude of tasks. It gives structural support, concrete combined with steel. It provides you with energy efficient insulation, EPS panels, thermal mass, and 40 plus R performance. Gives you strapping and furring opportunity, air vapor barrier, and is also finishing substrate, which allows you to do drywall on inside and all the exterior materials after you're in the phase where you're finishing the house on outside. Now, the main point in this video will be the key to ICF, to understanding ICF, and that is ICF Effect. And by clicking this document, it's an Adobe document, you can find this two-page brochure or paper or document, however you want to call it, which was produced by Insulating Concrete Form Association, as you can see here. You can find them by going to forms.org. I'll show you where to go later during this video so you can find it yourself and study it in more detail. So the ICF Effect document brings together a lot of very important points to understand what ICF really is about. A lot of people, especially in North America, are so used to conventional stick frame using lumber and batt fiberglass insulation to insulate the structures that many don't even realize that there are other ways to construct their homes. But this document really gives a fairly concise and clear overview of why ICF is far more superior than conventional building methods. So let me read some to you. Sure, you can read yourselves again, and I encourage you to do that, but I feel like this is important, and I'll go into some of these paragraphs which might not be ever heard of. So, while R values have been a traditional measure of energy effectiveness, evidence now points to other factors which contribute equally to energy efficiency. This is the rest of the story of the ICF effect. The R value measurement came about in response to the oil crisis in the 1970s. Up until then, fuel was cheap and minimal attention was placed on energy use, as evidenced by the lack of insulation in mid-century homes. The skyrocketing fuel prices triggered a need for immediate improvements in residential energy efficiency. Minimum insulation values were prescribed as a quick and immediate remedy. The values were based on the insulation materials typically used at the time. The existing hot box testing method measured resistance of heat flow, or R value. The R value testing measures the resistance to heat flow of a given material in a steady state. While not an ideal representation of real-world conditions, the R value provides a straightforward system for comparing insulation materials. As builders adapted new insulation materials and the HVAC industry developed more accurate equipment sizing software, one thing became quite apparent. R value alone does not reflect the true effectiveness of a material when installed. If it did, then a wood frame house with an R19 fiberglass bat would have the same energy performance as an insulated concrete form ICF house with R19 polystyrene foam, all other parts being equal. However, houses built with ICF exterior walls typically require 44% less energy to heat and 32% less energy to cool than comparable frame houses. What's the difference? We call it the ICF effect. So, I would like to go forward and get into reduced air infiltration. Over half the energy loss of a frame home is due to unwanted air infiltration and heat loss through the wall assembly. Air can penetrate into a building through many channels: sheathing gaps, penetrations at balconies or cantilevered floors, and insulation gaps in the wall cavity. Also, humidity and drying of the wood frame causes movement in the wood framing and contributes to post-construction leakage. Now listen to this. Air infiltration coming from these gaps is typically around 0.5 ACH, air changes per hour. Now, which means that each hour, half the air volume of a house is exchanged for outside air that needs to be heated or cooled. I'll read that again, and this is key. Air infiltration coming from these gaps is typically around 0.5 ACH air changes per hour, which means that each hour, half the air volume that's inside the house is exchanged for outside air that needs to be heated and cooled. Next point, thermal mass. The benefits of thermal mass have been enjoyed in practice for centuries. Recently, the scientific community has also quantified and validated this effect. Studies conducted by the U.S. Department of Energy confirmed that concrete mass in exterior walls reduces annual energy costs in buildings. In 1987, this was written into Energy Code in the form of reduced R value requirements for thermal mass wall assembly. And you can see here in this graph how temperatures are equalized with help of thermal mass. See the blue line, internal temperature or interior temperature is a lot less aggressive in terms of swings from colder to warmer. So the ICF concrete core offers the characteristic thermal mass qualities of heat absorption and thermal lag. The additional insulation of ICF wall further delays the transfer of heat to the inside of the building. This combination serves to reduce and delay peak loads, which may result in lower off-peak energy pricing and reduced HVAC equipment sizing. In climates with large daily temperature swings, the mass wall can release absorbed heat energy to the cooler night air, a process called heat flow reversal. This insulated thermal mass application provides an excellent pairing with passive solar design. The ICF wall moderates indoor temperature swings and reduces the amount of heating cooling needed. Now, finally here, to keep it short, I would like to read this part here. The U.S. Department of Energy has set its goal even higher, aiming for a net zero energy home, which is certainly not anything new anymore. Such a house will remain comfortable even when utilities are disrupted, providing passive resistance to disasters. The only way to make this economically feasible is to improve the thermal envelope for a lower overall HVAC load and thus yield a more affordable renewable energy package. ICFs can help provide this solution. And finally, it's time to look beyond the R value and learn the rest of the story. Insulating concrete form construction offers a complete energy solution that makes economic sense today while helping to meet the energy needs for future generations. And I'd like to encourage everybody follow the links that you can find on integraspecicfnewjersey.com, as well as going directly to forms.org site, which is now it's called EPS, Industry Alliance, Insulated Concrete Forms, formerly ICFA, Insulated Concrete Form Association, forms.org. And if you click on benefits, you will see a pop down column of features. You can do energy savings, comfort and quiet, wind resistance, fire resistance. You can verify and learn about all of these aspects of ICF benefits to you. This is the actual folder open where you can see energy benefits, peace and quiet, and links again for energy savings and comfort and so on. Now I thank you for watching, and I just want to again emphasize that ICF Effect document is probably the first thing you want to do if you want to learn about ICFs and realize why ICFs are key to energy efficiency. The synergy of higher R value, virtually no air infiltration, and the added thermal mass in ICF assemblies result in performance that simply can't be duplicated with traditional framed assemblies. And this is by David Shepard, Director of Sustainability, Portland Cement Association. Thank you for listening, thank you for watching, and good luck with your research, and hope you use ICF for your next building. Take care.